Hi, welcome back to Pluralsight and this module on Common Protocols and Services. I'm your instructor, Christopher Reese. Let's go ahead and get started. All right, so Common Protocols and Services. So in this module, we're going to cover protocols, ports, and everybody's favorite, the OSI model. If you've taken any networking courses in the past, you're probably already familiar with the OSI model, and you're probably sick and tired of hearing about it, but we're going to cover it a little bit here, just so we understand how all of these protocols and ports fit into that model and the corresponding internet model. And then we'll also talk about the security considerations of these various protocols and ports. Okay, so we have some protocols to go through. We have a number here that I won't read out, piece by piece. We'll go through them as we go through them. But understand that we have protocols that we need to understand. We have ports that we need to understand as where they fit, what protocols use what ports, okay, the common, well-known ports. And then we'll also talk about the OSI relevance, as I mentioned, where it all fits, and the security considerations. All right, so let's go ahead and just start off with a little bit of a background on the OSI model versus the internet model, for those of you who may or may not be familiar with it already. Okay, the OSI model, as we know, is a 7-layer model, and the 7 layers are the application, presentation, session, transport, network, data link, and physical. Now, there's an easy way to remember that. If you need to recall that on a test, you just use, it's very typical. Every course kind of goes through the same information, but you just basically create a sentence that has the first letter of each of these words. So you can either use things like all people seem to need data processing. That way it starts from top to bottom. Or you can say something like, please do not throw sausage pizza away, right? Or you can create your own, whatever is most applicable to you. But that's a good way to try to memorize when you have multiple kind of layers or multiple pieces to a problem to memorize or to understand. Create a sentence around it. That way it's easy for you to recall. All right, so the OSI model itself matches up against the internet model, which is the application, transport, internet, and network access. The application layer is comprised of 3 layers of the OSI model: the application, presentation, and session. The transport layer is a one-for-one. The internet layer, as you might guess, dealing with networking and so forth, that's a direct correlation to the network layer. And then the network access layer is a combination of the data link and physical as it pertains to the OSI model. Okay, now as you'll see on the right-hand side, some of the protocols and where they live within these different layers of the internet model or the OSI model. You'll notice at the application layer, we have things like Telnet, FTP, SFTP, SCP, and all of these things we'll go through for the most part as we go through this module. So SMTP, POP, and IMAP, which are your mail protocols, HTTP and HTTPS, which deal with that, obviously web browsing, DNS, domain name services, SNMP, for when we want to manage devices, simple network management protocol, NetBIOS for name resolution, WINS, things along those lines. At the transport layer, we have TCP and UDP, transmission control protocol, and user datagram protocol. And again, we'll cover all of these in more detail in just a few. You can see at the IP layer, what we have here, IPv4 and v6, address resolution protocol and reverse address resolution protocol, ARP and RARP, ICMP and IGMP. And again, you don't have to understand all of these. I'm just giving you an example of what protocols live at what layer of these various models. And then at the physical layer, or the network access layer, we have physical protocols such as Ethernet, token ring, frame relay, ATM, SONET, so on and so forth. Okay, just so you have an understanding of each of these layers have specific parameters of what goes there, how it functions, and so forth. Okay, so for the internet model, well, let's take a look and say, what does this mean when we have putting information on the network? What happens? Okay, so if I have an email that I want to send, or I want to retrieve a web page or so forth, how does that really relate? How does this OSI model or this internet model kind of relate to that? Well, let's say, here we have the internet model, which is again comprised of application, transport, internet, and network access, and I want to put some information on the wire. So what I do is I create a message, again, an email, a web page, what have you. I do something that initiates a transfer of information on the network. So what happens is I have the payload rather, which is really just the essence of my message. It's the actual piece that I generate. Okay, that's the message. That takes place at the application layer. Now, keep in mind, no layer in the internet model can talk to anything other than the layer above or below. Okay, the application layer can only talk to the transport layer. The transport layer can only talk to the application layer or the internet layer. And the same goes for the OSI model, only the layer above and below. And it's done in that fashion to make it very modular, so that you can pull out any piece of either one of those models Okay, you can pull out the internet layer and put in a different protocol. So in other words, the application doesn't need to know if I'm going over HTTP or HTTPS. It doesn't need to know if I'm using IP or IPsec. All it cares is it communicates with the transport layer. And as it flows down the stack, the internet or the networking layer can be pulled out. I can take IP out and put IPsec in. It makes no difference. The application, in other words, doesn't have to know a different way of communicating with IPsec versus IP. Okay, so the payload is then passed from the application layer to the transport layer. We add additional information, turning it into a segment. From the transport layer, it gets passed down to the internet layer, where we add additional information, networking or addressing information, turns it into a datagram. From there, it's passed on to the network layer, where we add additional information, cyclical redundancy check or CRC, so that we can ensure that the packet of information arrives in the same condition that it was sent at the receiving computer or the receiving node. It then strips off the framing information or the information that was added at the network layer, passes it up to the internet layer, strips that off, passes it up to the transport layer, and then at the application layer on the receiving machine, we're left with the original message. So then it gets passed up to the recipient.